Hello, everybody, and welcome to the Learning Engineering Podcast. I'm Dr. Scotty Craig, your host, and I am joined today by my co-host, Stuart Rice.
Hello, everyone. I'm Stuart. I'm a graduate student with Scotty in the Human Systems Engineering program at Arizona State University and also a staff member here at ASU. And I'm delighted to introduce today's guest, Mike Sharkey.
Hi there. Thanks for having me. Folks, I'm Mike Sharkey. I work at Arizona State University, and I am the Executive Director of Data and Analysis in the Enterprise Technology Department. So that is our IT department, and I manage our data. So this is our data analysis, data warehouse, and tools that are used by folks across the institution.
Thank you so much for joining us today, Mike. I think we're having a really interesting conversation because, one of the big areas of learning engineering has to do with data analysis and data analytics. So I think we're going to have a lot of fun today.
Absolutely.
I want to start out by asking kind of how did you come to here? What training did you need to actually get to the point that you're at now?
Sure. So formally, I'm a math major undergrad with a computer science minor, and I have an MBA in grad school, so sort of the technology business side. But kind of getting me to this point, there's probably one moment that I think is most seminal in this, and I was working at the University of Phoenix in the mid-2000s, and I was also teaching there. So my job was in data, working with data warehouses, but I also taught courses. I taught about one course a year over a 10-year span. And as I got more into the tools that we used, algebra tools and discussion forums and learning management systems, what I found was I could teach a course in the evening, so asynchronous online discussion forums, and then the next day in my job, I could go run queries and look at the rows of data that myself and my students created from being in that course. So making as direct a tie as one can between what happens in the classroom, the learning in the classroom, the learning environment in the classroom, and how that is represented from a data standpoint as a row in a database. And having that ability to both teach and then see the data really connected the dots in my mind. And so I always go back to that point as seminal, as saying, man, what we're doing here in the classroom, digital learning, technology, it leaves artifacts, it leaves remnants behind. And there's value in those artifacts. And so since then, I've done many things, but I think having the background of being in math and an analytical field, but then also that actual hands-on experience as a teacher and seeing how the data falls out of the back end, I'll always say is kind of the most important thing that got me down this path.
That's amazing. So what did you actually do with the data? So when you actually found out, like, hey, I can actually get this data on my students to see exactly what they did, how did that change what you did?
So it wasn't a creepy FERPA thing, right? And I would say I used it less for me teaching that class than I did for my job. So my job at that point with the University of Phoenix was in learning technology. So the computer science department wanted to use some automatic programming tool in their curriculum or in a course or two. I would work with those vendors to get the tools integrated. And then we would want to say, well, hey, is this tool helping? We spent X dollars on this tool to use some automated programming, adaptive programming tool. Is it making a difference? Well, in order to do that, we have to assess. And that's a data thing. And so what it did for me by teaching the class and seeing the data, I didn't use it to help me become a better teacher, although that is absolutely a valid and positive reason for it. It helped me in my job, which was how do we get to this point of determining the efficacy of tools, or at least going down that path and how to try and show that. Showing it is an incredibly difficult thing, right? From an A/B test, did this thing make a difference? Did it work? Random controlled trial, a huge kind of ball of wax to be able to do that well. But to at least start down that path, to be able to do descriptive analytics, now it's like, hey, I know what's happening. I know what data I need to look at. I know this is LMS data. This is tool data. How do they integrate? I could stitch together the entire transcript of what happened in the class from a data standpoint because I knew the front end, teaching the class, and I knew the back end, the data artifacts that fall out.
That's great, and I think that's actually a wonderful example of the learning engineering process, actually. Now, I want to shift gears just slightly to talk about kind of your journey in getting here. You've already talked about that some, but can you kind of tell us more about your kind of learning and engineering journey as far as like, how you got to this point in your career?
Sure. There were a couple of very discrete projects and things I've worked at that really built well upon each other to get me there. So I mentioned I was at University of Phoenix. So as we had access to these data, it started to dawn on my colleagues and I, hey, there's value in here, right? So the age-old thing of here are these atomic pieces of data. How can I assemble them in a way, interpret them in a way, utilize them to provide value for the institution, for the students, as much benefit as we can? And so we worked on a predictive model. What we were able to do is to look at activity in the online classroom. A student logged in, a student posted something in the discussion forum, a student turned their assignment in, and we built a model that said, what's the probability that a student will attend class next week? And so in this environment, the classes were 5, 6, or 9 weeks long. So attending in a week, which actually had a definition, attending at that point was 2 substantive discussion posts a day on 4 days out of the week. So we had a very clear definition of what attending meant. We had current and historical data of the learner, and we built a model to say, given what I know about this student, past and current, can I predict, will they meet the attendance requirement for next week? And we did a decent job at that. And so that's a tool we used that was wonderful in its impact, did some very good efficacy studies and used it for many years at the institution. So that was a very hands-on, from raw data to a problem we're trying to solve to an actual product. Around the same time, there was another project that I worked on that showed me the value of collaboration in the higher ed data industry around this. And so I was with a group, it was a Gates Foundation funded project, and it was data from 6 institutions. And we pulled those data together to try and get common definitions of data. One of the principals on it, Ellen Wagner, has been involved with Icicle and IEEE and learning engineering for years. And so we had this great collaboration. We had 2 two-year colleges, 2 four-year colleges, and 2 for-profit colleges. And we pooled our data together to say, let's talk about our common definitions, because we're all talking about activity in a classroom, looking at learning engineering, and how can we define that? So this was in 2010 or so, and it was wonderful to be able to say, hey, we're different institutions, but we're doing this in the same way. We're getting the same data. We're measuring learners in the same way. And then another big thing was I actually started my own company doing predictive analytics in higher ed. So I mentioned the model that we did at University of Phoenix. In 2013, I started my own company called Blue Canary. And we took SIS, Student Information System, and LMS, Learning Management System data from an institution, built a predictive model. Will they attend next week? Will they pass this class with a C or better? Will they come back next semester? And I had that as a company that I started up and ran for a few years. So a lot of things that sort of scaffolded each other as I got deeper into data and to how we could apply that for value.
Those are great examples. You alluded to learning engineering in those examples. So, but can you remember kind of when did you first learn about the area of learning engineering? Do you remember how that happened?
So from a definition standpoint, I mentioned working on a project with Ellen Wagner, who I think was involved very early on in the definition. And I'll admit I was skeptical at first. Putting a label on something, I'm like, that's data analysis. That's scientific method. It seemed like, a bit contrived for it. And so there's some good articles that my colleague Ellen did with talking about, going back to Herbert Simon and coining the term in the 60s and, applying the analysis to learning itself and how it's really picked up in the last decade or so. And so I've never considered myself a learning engineer. I'm just a guy who loves education and likes to play with data, but that might be a colloquial definition of learning engineering, so I'll take it.
That's great. And a lot of times in the learning engineering area, there's a lot of people who will argue that people are not truly learning engineers, but we have a learning engineering process. So now you've already given us really great examples in some of your previous work, Mike, about learning engineering projects. Are there any other learning and engineering projects that you'd like to share with our audience that you've worked on recently, maybe here at ASU?
Yeah, at ASU, I was involved when we switched our learning management system from Blackboard to Canvas in the 2019 timeframe. And so my team brought in the Canvas data. And again, the same mindset of, hey, there's value inside these data. What can we do with it? And so one of the first things my team built was taking the data from Canvas. So a student is in a classroom and they are posting and submitting assignments and exposing that to folks at ASU who find value. And so, again, being very cognizant of FERPA and privacy, right? FERPA is does someone have an academic reason to be able to see this information? We have a role at ASU called a success coach. So they are an advisor, not like here's the courses you need to take next semester advisor, but hey, let's talk about time management. How are you doing in your classes, right? A coach in that respect. And we pulled out data from Canvas, from the learning management system, and we made it available in a fashion for our success coaches so they can say, hey, I'm talking to a student. I can see how involved or active or not active they are in the classroom relative to other peers, how they're doing grade-wise, submitting assignments. So in my role in helping that student succeed and do well, I'm now more informed. So no data science, no magic predictive models. It was very descriptive of what's going on. And we have that being used in many, many departments across ASU to give these success coaches access to data so they can do a better job helping students succeed.
That's really interesting. For the success coaches, how did you set up the data for them? I mean, how do they get that data? Is it through dashboards or other forms?
Yep, it's through a dashboard. So we worked collaboratively with them to say, hey, and I'm talking whiteboards and markers, right? Here's what we can have. Here's what I could draw this chart for you. I could draw this graph for you. Would that be helpful? And so we did a lot of iterations to get them to a point where they now have access to a dashboard and they can pull up a student and see this information about him or her.
That's great. And it's the fact that you were able to actually connect with them and make them part of the process itself is actually such an important element of the learning engineering process. So,
we talk about, proving efficacy. And so, somebody asks, well, are these dashboards working? Are they helping? And I specifically did not go down the path of, are we retaining more students at a better rate because of this dashboard? Because there are way too many variables to be able to tell. So we took a more qualitative approach and we talked to 80 of the success coaches and said, one question, do you feel like you are a better success coach because you have access to these dashboards? Everybody said yes. And I said, look, if they feel they are better at doing their job, I call that a success rather than trying to go down this quantitative, did we move the needle? Because I've played that game multiple times. I've won that game once. I had one example where we did well with it. Others where it's hard to believe because of all the variables that are in play.
Yeah, it is so important to understand the types of data that you might need to answer the questions that you actually have. And sometimes that's quantitative, sometimes it's qualitative. And in this case, yeah, I think looking at kind of the coach's self-efficacy of how well they're doing their job is actually a perfect dependent measure for outcome.
Yeah. And because we're dealing with learning and not buying widgets from Amazon, right? You know the deal. It's hard to do A/B testing. Like, let me give this beneficial thing to half the students, but not the other, and see what happens. Like, hey, that's not ethical. So we know that it's not as easy to do kind of consumer A/B testing in education as it is in other places.
That's very true. And sometimes it can be more harmful than
Yeah.
helpful. Mike, you've had a very interesting career up until this point with a lot of different projects. Would you be willing to share any of your lessons learned with our audience, either from the projects you've talked about or in general?
Sure. I'll talk about two things. So first one's very tactical. Get your hands dirty with data. Get good at SQL. Walk around, explore. Nothing helps more than getting lost inside the data and seeing what's there. I mean, I use words like explore and storytelling and forest and looking around because it is that way. It's not the Matrix with green characters falling down the screen, but it is getting into the data and running a SQL query and let me just take 1,000 rows of data out of here and put it in Excel and look at it and sort it and filter it and see what's going on. And I'm going to sort it by student. I'm going to sort it by timestamp. And, oh, wait, there's weird gaps and that doesn't make sense. You as an individual, as a data scientist, learning engineer will become so valuable by having that domain expertise. Now, the challenge is it is domain expertise. That's great for Canvas learning management system, but now you have some other tool. You got to look at those data. It's not like you learn it once and it works for all. If I started off my career as a software programmer, right? I know that, a little bit of garbage in, garbage out. And so getting your hands dirty, looking at the data will pay off in spades. So that's a lesson learned I always share and tell people, don't be afraid to get your hands dirty with the data. Second thing I'll say is a little semantics. We talked about the moniker of learning engineer a little prior, kind of late 2000s or so, after the big data wave was hitting. There was learning analytics, and that's still around as a tag, and it has a Venn diagram overlap with learning engineer. But a colleague years ago wrote an article about learning analytics versus learner analytics. And the gist of it is calling something learning analytics means you're analyzing learning, analyzing the process of learning. Does this student know how to add mixed fractions? Learner analytics is more about what do we know about that individual? What do we know about that learner and their propensity and their background? It's really, really hard to do learning analytics. Measuring learning, looking at data to measure learning is really hard. I give an example. I mentioned, Amazon, right? How do you know if something was successful at Amazon? Really easy. They hit the buy button, right? You know it worked because they bought the thing. There's no buy button in education. I don't do a bunch of math problems and then say, I got it. I'm going to hit the button that says, I now know how to add mixed fractions. Doesn't happen. You may get it, but then forget it. You may learn it 5 days later or 2 years later. So we don't have that feedback. And so measuring learning is really hard. There are a very, very small number of folks I've seen in this field who've done a good job of measuring learning, and it's usually limited to quantitative fields like math. And so learner analytics is great, right? What do we know about the individual, their propensity? We can predict, will a student do this? But it's sort of the semantic guy in the, measuring learning is very different from measuring the learner. And that I go back to because people want to do learning and measure learning. And it's really challenging, not saying it shouldn't do it, but, let's do something that's actionable that we can help our students out with.
Thank you for those, Mike. I think they will be very important and useful for our audience, especially that distinction between learner and learning. So now let's move on. Actually, we've come to kind of towards the end of the show. I've been asking you and trying to pull out a lot of information from you, but I want to kind of open things up to you now as far as, is there anything else that you would like to talk about or promote?
I've been higher ed for over 20 years now, and I love being in this field because at the end of the day, it's about helping students, helping them learn, helping them succeed. Speaking as a collective, we as learning engineers are in a great position to do this and to enable this. But in higher ed, there's sometimes a propensity to overanalyze and research and, continue on to a point where you're in this cycle of research and never get to the practical solution that can actually help someone. And so what I always want to implore people is to have this product mindset. Hey, I've done a lot. I've dug into the data. I've opened up the box of Legos and started playing around. But now I'm getting to what's the thing I'm going to build? And how would I build this so it works and doesn't break? How will I build this so it works for 1,000 students? How will I build 1,000 of these things, not just one of these things? Going from that research, experimental, exploratory to practical product, in production and delivery is something that we see less of, especially by nature, right? We're in education, we do research, that's what we do. But having that mindset of, I'm going to figure out how to do something, and then I'm going to productize it. And I don't mean everyone's going to become an entrepreneur and sell it for a lot of money. I mean, make it something that we can actually put in operations and implement so that we can help and hopefully help at scale. Having that mindset, I think, is great. So I've seen a lot of divisions over the years of things get stuck very much in the research side and don't make it out to the product or operational side. And again, it's helping the state of the art. But I think people in this field, if they have that mindset of how am I going to make this happen and make this work in real life, is a good mindset to have.
Yeah, and I think that's actually, that's a great point. And that with learning engineering, we really do have to focus on solutions.
Yeah, and the predictive modeling, machine learning. So when I had my company 10 years ago, that was hard. And the fact that we could build these models was part of our value. Today, and I love this, I could go get a senior from the university as a student worker, and he or she can build that predictive model on their laptop in 2 weeks. And now I love that. Now that means that it's taken that mystery of how to do that heavy lifting out. However, going from a model on your laptop to something that runs with millions of records every day is still a big lift. So closing that gap is what we're talking about.
No, exactly. And that's why it's really important to actually then look for scale up. And if you don't plan for scale up early, it's very likely to fail.
Yeah, agreed.
So I think I have just two questions that I'm going to formulate in this way. So building on what you've shared about data analytics and learning versus learner, right? What lessons have you learned about what to include in a model and what becomes valuable in a model when you're thinking about analytics in this field or in this area?
It's thinking ahead about what's actionable. So when I had my company, we did predictive model, will a student pass the class with a C or better? And as the main salesperson, I'd be talking to institutions and we get into the intricacies of the model. Rightfully so, right? I'm not trying to sell a black box to someone. I don't want to try to seem like we're doing magic. But I would pause at one point and say, I said, here's the part where I become a really bad salesperson. I said, I want to talk to you about, is it right? Is this right for you? So let's forget the predictive model. Let's assume I have a crystal ball, and I have a wonderful crystal ball. And I say, crystal ball, give me a list of 50 students who are going to drop out in the next 2 weeks. And it spits out a piece of paper with 50 names on it. My question is, what will you do with that list of 50 names? So I'm not asking how the crystal ball knows. I trust that it's magic and it's perfect. But the important thing is, what's the actionability? What will you do? Like, are you going to go to committee? Are you going to someone to call them up? Is it give the list to their professors? There's a lot of ways to approach it. Think about that ahead of time. What is your intervention? How will that happen? Just making the information available is one thing. You need to say who is going to take action and how will that happen? And so that always comes into play. The work we do here at ASU, a lot of time is spent socializing and working with the folks at the different colleges so they can take action on this.
So thank you for so much for that. And just a follow-on question. One of the working definitions that we often use is that learning engineering is a team sport, bringing together a lot of different discipline areas. And you just sort of hinted at that by talking about how these aspects of data are being sort of couched or contextualized within a larger team who's taking action on it. As you sort of think about in the spaces you've worked, what are the team of people that are coming together around questions? What do those teams look like? And what shared goals do they have, if any?
Sure. I'll highlight a few roles. So there's the technician, right? So call it a data scientist, call it a SQL jockey, right? There's someone who gets their hands dirty with the data. So that is absolutely necessary and a role that you've got to start with. You then have the subject matter expert. So that is the person who understands the data. Now, sometimes you're lucky and you get a unicorn and you get someone who does both, but not very often. So that subject matter expert, they understand the learning environment. They understand how courses work, how teaching works, synchronous, asynchronous discussion. You can't have someone looking at these tidbits and tea leaves of data without having someone else who knows, oh yeah, of course you get nothing on Monday because we don't have class on Monday. So you're going to have blanks on Monday and don't expect to see anything. It's not an anomaly. It's it's by design. And then the third role, I think, leads to more of my implementation kind of businessy way of who's thinking of this as a product, the product owner, a product manager. How is this thing going to work? Who are we going to need to make this thing run in operations? Who is the customer for it? Are we designing for the customer? Those three roles, the kind of hands-on data analyst, the academic learning subject matter expert, and the product manager are usually different and orthogonal in their skill sets. Again, you might get lucky and get a twofer or a threefer, and someone can cross over. And there's probably other ones in there, but those are kind of some of the core roles that I see.
Thanks so much for that. Scotty, back to you.
Now, actually going back to my other question, so you said you had this project where you were pulling together data from university level sources, community college sources, and some other sources, trying to actually work on getting them to use like the same language, and I'm assuming similar formats also. And I was wondering, how did you do that? I mean, because there's architectures now, such as like XAPI, which allows you to standardize that, and learning record stores, which allows you to save things into the database, and then you can easily put those into data lakes across. But how did you handle that? Because that was many years ago before a lot of this stuff was set up.
So it was less about the transport mechanism and more about the packaging. And I use the analogy of shipping. I could send a box by air or by truck or by car, but then there's also, what am I sending? Am I just putting stuff in a box? Do I have a styrofoam divider that actually determines, what does the package look like? And so this is more the latter. So this was less about the technical, how do we get it out, which is like XAPI. If you've seen the caliper standard by One Ed Tech, so they have different metrics. So like an assignment, a discussion, an activity, they're defining. And so we kind of got to that level. It was a little higher up. We were saying here are some SIS things like student gender and age and demographics, and then class and activity and grade in class. And so it was fairly high level, but we were talking about that. So basically, think of doing a predictive model and what are the features that you're including in the model. We were doing feature engineering and trying to do feature engineering that would make sense cross institution, not just like, oh, that works great at ASU, but not at this university. So we were doing feature engineering before we called it feature engineering in the kind of learner analytics space.
Oh, that's great. Thank you. That was the one thing I wanted to kind of clarify, because a lot of our audience actually knows XAPI and learning record stores, so that's what they were going to be thinking about. Well, Mike, I'd like to thank you for joining us today on the Learning Engineering Podcast. It's been wonderful talking with you. Stuart, thank you for co-hosting with me today. And to our audience, Thank you for joining us, and we'll see you next time on the Learning Engineering Podcast.